Okay, so this is for the later periods that didn't get to finish this practice. So this is looking at gross primary production minus respiration to see what your net is. Or if you have your net and your gross, we're going to subtract and find out what the organism used for respiration. Is that better without the lamp? I don't know. All right, anyway. Okay. All right, so a lot of us we all got through this top part. For example, to find the amount of energy lost in respiration by your secondary consumers. Okay, we knew what they had in there as their gross primary production. It's whatever they got from the trophic level above them. They got 598, and I didn't give a unit, so we'll just call those kilojoules of energy. Even though there was 2,389 available for them in the primary producer trophic level, there's no way that the secondary consumers can eat every single one of your primary consumers. That would never happen. That's not realistic. Additionally, when secondary consumers do eat your primary consumers, they're going to excrete some of that biomass as waste. And so it's not going to be incorporated in their body. And they're not going to eat every single part of these primary consumers. Like a rabbit is a primary consumer. You're not going to digest the fur. You're not going to digest its bones or its claws or its teeth. So we're not going to have all of this energy going into the next trophic level. So when we calculated number 1, we wanted to see respiration, which was X. We knew they had 598, and we knew that 67 was left over for the next trophic level. So we needed to know what they respired. So we took 598, subtracted 67, got 531. Okay, we did the same thing on number 3 for the respiration between primary consumers. All right, and then we're going to calculate trophic level transfer efficiency. I'm going to put the formula right on the side here. Trophic level transfer efficiency. Study your notes. It's the energy in the new trophic level divided by the energy in your previous trophic level times 100 to get it in a percentage. So the efficiency of energy transfer between the sun and the producers. Okay, in the sun, we have the values in scientific notation. So we're going to need to put that in standard notation. So 1.6 times 10 to the 6. It's going to be a big number. We're going to move our decimal point to the right 6 places because it's going to be a large number. So 1.6, we need to go over 6 places. 1, 2, 3, 4, 5, 6. Add zeros in all of these spots. Now it's in standard notation. Okay, and I can divide now. So I'm looking at the sun and the producers. The producers have 72,567 kilojoules of energy, and the sun is 1,600,000. Okay, let's divide that. 72,567 divided by 1,600,000. Okay, times 100, getting a percentage. 4.5. There's no other value here that's in a decimal, so we're gonna push that up to 5%. Now remember, you can ask the question of how come only 5% of the sun's energy is incorporated in the biomass of the producers? And then, just like you have written in your notes, calculate the efficiency of energy transfer between producers and primary consumers. My producers, 72,567, and my primary consumers is for 6,421. So it's going to be the new trophic level over the previous. So my new trophic level is my primary consumer, 6,421 over 72,567 times 100. $8.8. We're going to round that to 9. So I think in 6th period they asked, what about the 10% rule? It's not super consistent. It's not always 10%. That's something that we might teach lower level science classes, but now that you have the knowledge of respiration and net primary production, we can look at the specifics. It's about 10%. Sometimes it's more, sometimes it's less, depending on what you're consuming. And then they want you to do the same thing between the primary consumers and the secondary consumers. So we're going to be doing new trophic level over previous trophic level. All of your setups should be small number over big number. So 598 over 6421 times 100. Okay, 598 divided by 6421 times 100, 9.3. We're going to round that to 9. It's 9%. Okay, and that's trophic level transfer efficiency. On the back, this is going to be what your test is going to be like. Let me get one that I didn't write on. All right. So no, there are no units on this one right here. Kilojoules. So this could be a pyramid of biomass or a pyramid of energy. We're going to know it's a pyramid of energy because it says calculate the efficiency of energy transfer between phytoplankton and zooplankton. Come in. Okay. Okay, the phytoplankton is 8,000. And I'm already doing it wrong. It's new trophic level over previous trophic level. So 912 over 8,000 times 100. Okay, it's 11.4%. Calculate the efficiency of energy transfer between zooplankton and fish. So again, new trophic level over previous, it's 86 over 912. Times 100. 9.4, but there's nothing here in a decimal, so we're going to keep it at 9, which reminds me that this has to stay 11. All right, the average efficiency of transfer between producers and primary consumers is 10%. Suggest why phytoplankton to zooplankton is more efficient. I'll show you the answer for that when I get it. Amazing. Amazing. Okay, here it is. So the reason why is because they're consuming phytoplankton. Phytoplankton are easily digested more than terrestrial plants. Terrestrial plants have cellulose inside of them, so there's less cellulose inside of our phytoplankton. They don't need it. They're easily digested. Plus, they're consuming the entire organism of phytoplankton. Normally, it's 10% with any kind of producer transfer, but with phytoplankton, again, it's microscopic. You're eating the whole thing. Phytoplankton don't need to have like a ton of cellulose built into them to stop them against like falling when there is a flood or breaking in the wind. You know, plants are really, really sturdy, and that's not what phytoplankton has. There's less energy lost in respiration and heat in phytoplankton. It doesn't take as much to keep them alive as it does like a tree. And then again, they eat the entire organism. So that's going to be why there's going to be less energy in there. Okay. Tomorrow you guys will get a packet with different practice questions concerning this, but I think you should now have enough practice for doing trophic level transfer efficiency, and then calculating your respiration loss in gross primary production and net primary production.